Hi everyone. We're going to attempt to do this part of the lesson online, and we'll see how that works and if that's a good way of doing some of the concepts in the future and make sure we get through this unit on bonding before spring break. So today we're going to start with finishing up our scientist chart. We have two more scientists we need to add, and they are related to the development of the periodic table. This figure in your book is showing the discovery of elements throughout different time periods, but for a really long time, the knowledge of elements was a lot of just disparate facts. There wasn't a common organization system, or there wasn't the orderly pattern recognition that we got from the periodic table. In 1869, that changed with the development with Mendeleev. So we're continuing that chart from earlier. So we've got the person, the year, their contribution to atomic theory, picture of the atom, which isn't going to be relevant for these two, and the relevant experiment. So we're starting off with Dmitri Mendeleev. And he made his discovery, or he did this arrangement of the periodic table in 1869, and he arranged the elements by atomic mass, and which think for a moment, remember what the atomic mass is. That's the combination of protons and neutrons. Arranged periodic table by atomic mass. And he doesn't have an experiment or a picture of the atom. And so this is in 1869. So for a moment, think of why he might have chosen atomic mass instead of atomic number. I'll give you the moment to think. So at this point, the structure of the atom, you can see from earlier in the chart, they didn't really know about those structures. So the electron wasn't discovered until 1897. The proton, we'll see with the next discovery, or the nucleus was discovered in 1909. Our next person's the one who discovers the protons, and so he didn't know about the protons, so he of course wasn't able to use them. But arranging them by atomic mass, because the order of increasing mass is, for most of them, the same as the order of increasing atomic number. There were a couple anomalies that were then solved by arranging them by the number of protons. But it was able to it explained what was currently happening, and then he was able to predict the existence of new elements. So the example in your book shows Mendeleev's predictions for an element below silicon, the period below silicon, and germanium, which was discovered not long after, had many of those properties exactly as Mendeleev predicted, which showed his table to have really good predictive properties, which is part of why it's so helpful to be used. Your book attributes Lothar Meyer in Germany to have a pretty similar table, but it's debated how similar it was. Meyer's table didn't have all of the elements that were known at the time, and he didn't explicitly make predictions. So Mendeleev has the credit for basically doing more with the table and including all of the elements. So the next person on the list, the one who is responsible for the arrangement of the modern-day periodic table, is Henry Moseley. And he, in 1913, which is, if you remember, was the same year as the Bohr model of the atom, and 2 years after Rutherford, 2 years or 3 years? Rutherford discovered the nucleus in 1909, so 4 years after the discovery of the nucleus, Moseley he was working with X-rays, and through those, he developed the concept of atomic numbers. This is his contribution to atomic theory, which you remember is the number of protons. And he took it a step further and arranged the periodic table by those atomic numbers. And so that solved a lot of the, it solved some of the discrepancies. So your book points out argon, which is one of the noble gases. Argon has an atomic mass of 39.9, so essentially 40, or I guess we need to go in decimals. So 39.948, whereas potassium has an atomic mass of 39.0983. So arranging it by atomic mass, you get potassium coming before argon, but that isn't consistent with the properties they have. But arranging them by atomic number, argon has 18 proteins, potassium has 19, and so then they get into their proper positions. I mentioned that the experiment he did, there's again not a picture of the atom for this one, but his experiment was he was using high energy electrons, beaming them at elements, and measuring the X-ray frequencies that resulted. So, hit elements with electrons, and measured X-ray frequencies. So your book talks about it some. He was able to split those X-ray frequencies into whole numbers, and so that ended up being the atomic number. And he realized that was because of the number of protons. So that finishes out our scientist chart. Remember that the ones we've already done and these two are the main atomic theory scientists, all of the atomic theory scientists the SOL wants you to know. So hang on to this chart to study in May also. But in the next part of the video, I'm going to do it in multiple parts to make sure that the file is small enough to actually upload. But we'll go into some of the properties that the periodic table shows. One of the reasons it's called the periodic table is that it has different patterns that repeat. So something that occurs periodically occurs repeatedly in normal increments. And so you've got like every time you get back into that group one, these all pretty much have the same properties and etc. going across the table. So we'll look at some of those properties and see how you can, based on where something is in the periodic table, know pretty much what it's going to do, how it's going to bond. So that'll be next video.